Okay, so um, I can hear myself through recording, which is weird. I switched laptops, so it sounds weird. Anyways, I hate matrices. It is the worst subject I've ever studied in my life. It's the fact that I made peace with it the other day, and it's funny how my audio didn't work, you know? So I don't care. I don't care if no one understood because I'm making these videos just so I understand it myself. So I'm just gonna directly head on to the inverse of matrices, like inversing matrices, I guess. So this is the this is the notation for an inverse matrices or matrix. This is how a matrix would normally be, you know, noted down. But this is the inverse. This isn't the reciprocal. This isn't 1 by a. That's not the meaning. Just bad like what writing, I guess. So that out of the way. Um, just okay. So multiplying a number by the reciprocal of a number. Or this is probably a bad example. Multiplying a number with the reciprocal of a number will always equal to 1, right? So there's a similar thing in matrices, and instead of the reciprocal, it's the inverse, right? So a times a negative 1 is equal to I. Now I think I mentioned this before, but no one heard it, is just the identity matrix. So that's basically just, something that looks like this here. So this is basically the one of the like world of matrices, I guess. So uh what what is this? Oh my god, hold on, let me delete this. Okay, so we're back. I guess. And yeah, not gonna question what happened there. Okay, whatever. That's a stupid. Okay, so now okay. Basically, now let's try to find like let's see how we can find the inverse of a matrix, right? So let's say this matrix A, B, C. Okay. So that's our technical issues. So let's take the matrix A, B, C, D. Right. Find the inverse. Uh, it's a formula basically. So this is a two by two matrix, right? Now note that down that finding the two by two, like inverse of two by two, is pretty simple. So how we do this is we'd find one. So we'd find was it one over terminal A times. So we're gonna divide this entire matrix by terminal A. But before we actually put this matrix down, we have to do some changes, right? Remember this. We're gonna swap A and D's places. So D is gonna go here, A is gonna go here, and we're gonna change the signs of the ones here. So minus B, and this is gonna be minus B, right? So we have to remember this, right? So from here, uh, we know that 1A. I'm just simply like deriving this from mosquito. So 180 minus BC minus 2 minus 2 minus B C minus C. Okay, the writing is getting a bit sloppy. Weird, writing on a new laptop, whatever. So, uh, now this is basically the normal formula to get an inverse of a, what is it, of a, what, of a matrix, right? So, uh, let's say we're trying to find another, like, let's say trying to find, like, for an example, let's do another. So, if we're going to continue here, let's find a minus 1. So, or a, inverse of a. So, with the formula, 1 determinant of a, we're going to find, we're going to swap these places, 3, 2, then minus 4, minus 6. Right? Determinant of a, this is 6, right? So, uh, this is going to be 6 minus 20, or minus 24, which should be 18, or minus 18, times 3, negative 4, minus 6, 2. Now I'm going to quickly calculate this, because I am not doing this by itself. Okay, so basically, I mean, you guys are going to do division. Uh, each term, we're going to divide by minus 18. So 3 divided by minus 18, which is going to be minus 1 by 6. Right? Then minus 4 divided by minus 18, which is just going to be 2 by 9. Might as well write them the same way. 2 by, then minus 6 divided by minus 18. This can be 1 by 3. And this is just going to be 1 by minus 9. So, right, it should be 1 by 3 minus 1 by. So, this is how you'd find the determinant of a square like 2 by 2, right? So that's pretty simple. Now, next few, let's go through some properties now. Okay, so this isn't really a property, this is more of the question-based thing. If we're ever asked to find, let's say a matrix X into A, right, equals B. Now, normally how we would do this is we would divide, if let's say this is algebra, we find to isolate X, we divide both sides by A, right? So we cut this, and then we put A here, right? But we can't do that because we can't divide by matrices in this number system. So what we would do is we would multiply them by the inverse, right? And then it would equal to I, which is the identity matrix, which is basically just 1 when we're working with matrices, right? So let's do that. So A into A over 1 equals B into A negative 1, right? Which then this is just equal to A x x into I, which is identity matrix, and then B into A minus 1, which just equals, or let's just mean that x is equal to B A, uh, B into the inverse of A, right? Now, the thing is, one thing that should be noted is that since was it since the multiplication of matrices are not commutative, like they're commutative, what do you say? They're not. These aren't the same, right? So we have to do something else. If this was a different question, if this was ax equals b, right? Now what we have to do is again we wanna uh, we wanna get rid of this a. We wanna isolate x, right? So we do a minus 1 into a times x equals B, or this is actually equal to A inverse of A times B. Now, the reason why it's different is because if it's here, if this A is here, then we're gonna multiply it with something here, right? So, oh, right. So then, in turn, if we do that, then the other side of the same exact thing. It's not going to be the same if I put it here, right? If I did it here, it wouldn't be the same. So we would put it here. So then, from here, this would just be x, or right, x. We get these terms cancel, right, to a 1, and it would be a minus 1, b, which would in turn lead to very different results, right? So make sure you're not doing mistakes like that. Now for a property, I'm gonna write this a bit larger because we have space b a is equal to a minus 1, or I'll just write it like this, b minus 1. So when we're finding the inverse of two matrices that are multiplied together, we would have to find first the second term would go here, and the first term would go here, right? If this was AB minus 1, since AB and BA are different, they would have different product, right? So this would be the second term would go in start, so B minus 1, and then this would be A minus 1. So just multiply them. And yeah, these are equal to the same thing. So in some algebra, or maybe you're going to be asked to prove this, so like in some O-level questions. So yeah, just do that. Uh, one more thing. Not all matrices have to have an inverse, right? Sometimes, okay, so if the determinant, overall the formula is like this, right? A, B, C, D. Now this is the formula. Now, what can go wrong here? Something can go wrong. If the determinant is equal to 0, then what you're going to deal with is you're going to deal with something being divided by 0, right? Which we already know it's undefined, so we can't even do this to begin with, right? So there are some matrices with uh, no inverse, and they're called a singular matrix. So they're basically they don't have a pair, right? So yeah. Now next one, this next question is a bit hefty, so we'll go to that. Okay, so we found out how to find the inverse of a 2 by 2, right? So from here, let's figure out how we find the inverse of a 3 by 3, right? There's a lot of steps to it, but it's not that hard if you just focus a little bit. Let's remember. So let's take the matrix A is equal to 1, 2, 3, 0, 1, 4, and 5, 6, 8. So from here, uh, what we have to do is we have to find the matrix of the minors, right? So, funny name, minors, whatever. So, what we'd have to do here is this is a pretty grueling process. I'll do it now. I'll actually make this a bit bigger. So, we're gonna find the determinant. So basically, for the first term, which is gonna be A here, we're gonna find the determinant. The first term A is gonna be this, the determinant of this. So we'd find 1, 0. So this is 0, and then minus 24. So this would be minus 24. Then, uh, Let me just make it bigger for the sake of, you know, aesthetic. So next one, we're gonna cut this. So we're gonna have 0 to 0 to 0, and 4 times 5 is 20. So 0 minus 20, that is going to be minus 20. Right? Then we have plus 1. So cut this, cut this. So we have 1 into 5 minus 0 into, uh, wait, no, sorry, right. Uh, 0 into 6, which is 0, minus 1 by 5, which is minus 5. So this will be minus 5. Then next one. So now what we're going to do is, now that we cut these off, we're going to start working with this term. So this is what we're going to do. So it can't be in the same column, can't be in the same row. So this. So this is going to be 2 into 0, which is just 2 into 0, which is just 0, minus 3 into 8, 3 into 6, which is 18. So that's minus 18. Now here, now this looks a bit cooler. 1 into 0, which is just 0, minus 3 into 5, which is 15. So this would be minus 15. Now let's speed up the process. Let's do this. Well, this would be 10, and then, sorry, this would be 6, and then minus 10. So that would be minus 4. Uh, okay, now that we're done these, we're going to start doing these. Right? So this. So this would be 8 minus 3, which is 5. Oh, 5. Then this, which is going to be 1 into 4 minus 3, which is going to be, or sorry, 1 into 4 minus 0, so this would be 4, and then this would be 1, or the next one would be 1, it's 1 into 1, and then that's just 1, minus 2 into 0, which is 0, so now it's just be 1. So we found the matrix of minors. Of minors. So next one, since now that we have this, we're gonna, I'm just gonna draw this now so I can fill it in later. Okay, so we have minus 24 here. We have minus 20, minus 5, minus 18, minus 15, minus 4, 5, 4, and 1. So what we're going to do now is we're going to find the matrix of cofactors. So write this down, matrix. And this is not going to take as long as what we did before, cofactors, whatever. You can't read that one. Oh, whatever. So since it's a 3 by 3, what we're going to do is we're going to draw a checkerboard, right? This is, you have to memorize how this looks like. It's not that hard to memorize, just the negatives make a diamond and the pluses make a cross, or an X. So what? So from here, we would just multiply them together. So this is just gonna be minus 24, right? Minus 20 into minus 1 is gonna be 20. And then, minus 5, as like you see here. So 18, right? Minus 15, 4, 5, negative 4, and 1, right? Now, I'm gonna, remove most of the screen. Okay, so, I just had my sahari. It was 3 pieces of bread, like just bread by itself, and rapcha. So, I don't know, I'm just feeling depressed right now, whatever. So we found the matrix of cofactors, right? So now let's find, there's 2 more steps left, Okay, we have to find the adjugate and we have to divide. Okay, so let's go through that. Now, the adjugate is basically reflecting off the diagonal. So this isn't that hard. I'm not going to make much space for this. Now, the diagonal. This is the diagonal, right? And this is, wow, straight line graphs are not for me. Okay, so this portion of the graph, there, it's going to stay the same. So let's just draw that now. 24 minus 15 and 1. These are going to stay the same. Now, the opposite things here. Think what are things that are going to change? You're just going to reflect them, okay? So 18 and 20, we're going to swap them. Okay? So 20, 18. Now 5 and minus 5, we're going to swap them. So minus 5, and 5 here. 4, minus 4 and 4, we're going to swap them. So 4, minus 4. So let me see if I got everything right. Yeah, I did. So now the final thing. So this is the adjective. Adjugate just means, finding the reflection based, you know, off of the tag. So the final last thing we have to do is we have to divide this entire thing by the determinant of the original matrix, like matrix. So 1, 2, 3. If you remember what the original matrix was, it's 1, 2, 3, 4. 1, 2, 3, 1, 4. 1, 2, 3, 0, 1, 4. 5, 6, 0. Now, uh, you obviously don't know how to find a determinant. You guys don't even know how to find a inverse. None of you do, unless you read the book, right? And you would have if my mic worked before, but it didn't. So whatever. I'm just gonna steamroll through this. You'll understand later, okay? When I don't really do school or something. So minus 24, 18, 5, 20, negative 15. The reason why I'm giving like little to no space right now is because I already know the answer, so I don't need to do all this. So this is going to be divided by, you know, this whole thing. So 1 into 0 minus 24, so minus 24, minus uh, hmm, I just zoned out there. So that uh, now we're gonna do this. So we're gonna find minus 2. This is gonna be 0, 0, and then it's gonna be minus 20. So minus 20, and final one, this. So it's gonna be 0 into minus, or 0 to 6, which is 0. 0 minus 5. So this will be minus 5. So this is going to be uh, minus 24 minus plus 20, because minus 2 plus 40, sorry. Plus 40 minus minus, and 20 times 2 is 40, then minus 15. So if we did this on the calculator, we would find this would be minus 24 plus 40 minus 15. This is equal to 1. Okay? Determinant is equal to 1. So let's get rid of this entire thing. I'm not used to this. Let's get rid of this entire thing. And now we know the determinant is 1. So this entire thing divided by 1 is just the same thing, right? So minus 24, 18, 5, 20, negative 15, negative 4, 1, 4, negative 5. That's the answer. This is just the same thing. If this was like, I don't know, 2, you would have to divide everything by 2. So you're lucky it's by 1. So yeah, that is basically it for matrices. It's not it for matrices. this is it for the matrices or matrix operations. So this is so let me just little real quickly just summarize everything. For let's summarize everything for the 3 by 3 first. So here, down how it goes. So number one, we're gonna find uh matrix and minors. Haha, funny word. Bet anyone would laugh at that. Okay. So two. So matrix and minors is just finding the um A, B, C, D, G, H, I. So, keep on like finding determinants for absolutely everything. The boop and boop, boop, wait, I forgot. Boop. Yeah, whatever. Just keep on finding determinants. Then you will get the matrix minors and place them into the corresponding spots on your resultant matrix. Okay? Then matrix of cofactors. Cofactors. And what this is equal to, well, this is just multiplying by the checkerboard. So minus, 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 plus, plus, plus. So cross and then diamond. Remember that it's going to be helpful. I don't know if you're doing a MIT integration, which is very weird example, but this, if you know how to find this, if you've understood like this entire like I don't know video, then you could probably do one matrix question for MIT. It would be grueling, but you could still do it. Whatever. The next thing we're gonna find the adjective, which is just A B C D E F G H I. So this is reflecting by the diagonal. So this is going to be A E I. So draw this a bit better, just a bit. You can't make it too good. So B and D is going to swap. So B, D, then I or C. Sorry. Wow. Okay. C and G are going to swap. So C, G, and F and H are going to swap. So F, H. So this is what it would equal to. So if find the adjective, then number four, we have to just divide. So resultant matrix divided by, it's like absolute value of it. Oh yeah, sorry, determinant A. So that's all you have to do. Uh, if you recognize a pattern here, you can realize that this is basically the same thing as, finding 2 by 2, just very complicated, right? It's not hard, right? It's a simple like, method. It's just a lot of work, a lot of arithmetic, and you're very prone to make mistakes here, which is why, people may not, find it so, splendid, So, especially me, because I hate arithmetic and I'm not good at like doing a lot of it at once. So, yeah, this is it for the matrix operation. So, if you somehow followed by the last video, you would understand. What the hell? You understand the concept of matrix, the matrices. You would understand addition, subtraction, multiplication, these are multiplication. As you grow older, you stop seeing multiplication and division as different things, but like the exact same thing. And then you have determinants. Not saying I'm a fucking professor, but like, you know, it's easier to see them as the same thing. Determinants, and you found matrices. They're not inverses. So you are finished all the operations. Yay! Matrices, like easy chapter. It's not genuinely pretty easy, but yeah, that's it, I guess. So, peace.